Let me enable attendance. Okay, the attendance enabled, guys. Good afternoon, Kirti. Yeah, attendance is enabled. You can now mark your attendance. Guys, put the attendance. It's open. So actually, WebEx is having some problems again. So sometimes my voice simply goes off and not sure what's happening. So anyhow, some discussions before we start. So this week, we have a holiday tomorrow. So there will be another lecture day after tomorrow. I have to prepare a digression lecture for you as well. That is more to give you an idea of how a program is, how a program uh, it gets evolved into a process at the time of execution, and how processes are managed by operating system. What is the code segment? What is where are the variables stored? So there are some things I need to talk about. This is not really uh, this is not really something that is a part of the curriculum. So there will be no questions on this in the exam, but it will be helpful for you to understand the whole uh, concept of pointers. Pointers is something that we are going to talk about in today's lecture and on Wednesday's lecture. So if you go through that digression lecture, once I have prepared it and uploaded it, you will get more clarity. I will try my best to upload it before I upload the lectures for the next week. By the way, next week we are going to have the same model as of now. So I will upload the lectures and we will have a discussion. But during this weekend, I think Shreya is going to send another email to you guys. After we have done these two live lectures, you will now have an idea that how would a live lecture go, and how does the current model that we have been using till now, how is it different? What are the pros and cons? So then in this weekend, we just need to have a simple questionnaire, a binary thing where you simply say, I prefer live lectures versus I prefer, offline lectures plus discussion. So whatever you want, just vote for that. And because this week we are also going to have a look at how live lectures go. So after this week, we will decide on the fate, like what is it that we are going to do from next to next week. Okay, that is the first thing. Second thing, I tried creating an account on Microsoft Teams. Um, I'm not sure what options should I have chosen, but I chose to be an educator. There is an option that whether you are a student or an educator. I chose the option of being an educator, and I received a message that someone from the administration should log in and create some account, something like that. So I'm not sure exactly how to go about when it comes to Microsoft Teams. So if any one of you have, I think some of you have already tried Microsoft Teams. So whomsoever would like to help me, just drop me an email and tell me like what is the way to go about with Microsoft Teams. If Teams work out, maybe the next week lectures will be on Teams, but that is based on if I am able to comprehend their whole process and their model. Okay, if I am able to do that, then from next week onwards we may switch to Microsoft Teams. Otherwise, the default is WebEx only, right? Okay, how many people do I have now? 74, I think. It's good enough. I only have 59 responses on the attendance, so uh, you know just mark your attendance. It will be good that you get that out of the way straight away. Okay, so this is a live lecture. I am going to share my screen now. Okay, can you guys see my full screen now?
Yes,
um,
sir.
yeah, by the way, when I give live lectures, I will not be able to look at your chats. Okay, so if you have any questions, you will have to actually unmute and ask, because I will not be looking at chats. So if you want to ask, just unmute and I'll stop. Okay, so we are now in week 6, and this week actually we only have 2 lectures, today and Wednesday. So we are going to cover a very common, a very cryptic, what can I say, a concept that a lot of people dread, to be honest, when it comes to C and C++. The concept is very simple. However, the possibilities that are there, when it comes to using pointers, they are so vast. And because there are so many pitfalls in which you can fall as a developer, this is probably why people actually dread using pointers. But as a concept, it is a very powerful concept, and this is probably the only exception where I'm teaching you something that is language specific. Okay, because pointers, I don't think other than C and C++, uh, I'm not sure which other language in the modern day allows you explicit manipulation of pointers. Okay, all these languages like Python and Java, they don't give you this facility. Okay, so pointers is a facility that you get in C and C++ only. Only, I mean, okay, let me not use the word only. There may be some other languages which I don't know, which I have not worked with. So sorry, I should not have said only. But to the best of my knowledge, all modern um, day programming languages, they actually avoid giving the control of pointers to developers, because there are so many ways in which you can actually goof up, right? And we will see one of that in today's lecture, and we'll continue this lecture in the next part, which will be on Wednesday. So just a recap of something that we have already seen. So what really happens when we declare a variable? Till now, whatever we have discussed, we basically said that as soon as you declare a variable, some space is allocated in the memory, and that space can now be used for storing a particular value. Okay, that space could be for storing integers, floats, double, whatever it is, right? But basically, some space is allocated where you can store a value, and we actually assign that particular space a particular name, right? And that is the name of the variable, and that becomes a kind of alias for that memory location. So for all future accesses, whether you want to assign something, whether you want to read that particular data, you simply use the name of that variable. Another concept that we already know is the concept of arrays. Arrays basically are a collection of variables. The good, the special thing about this collection is that they are allocated memory contiguously, right? So one after the other. If you have a 5-element array, you basically are having um, five variables one after the other in the memory, and in order to access any particular a member of that particular array, we simply use an index. Okay, and this index starts from 0 and it goes up to 1 minus the declared capacity of the array. Okay, so now some languages like C and C++ also allow you to know more about this memory location. And this is why I said that, it is not something that all the languages allow, because it is not always necessary that, right, for you, it might be just enough that some space has been allocated in the memory. You probably don't really want to know much about where this space is. But some languages like C and C++, they actually allow you to know more about the memory location itself, where your particular variable is going to store the values. A pointer is a variable that stores the address of another variable. Okay, so this is the difference between a pointer variable and the so-called regular variables that you have, right? So a pointer variable does not really store values. It actually stores the address within the memory of another variable. So in such a case, what you can do is you can always use the variable name to access that location, as you have been doing till now, and at the same time you can actually reach the same location in the memory via the pointer variable. So there is a kind of a redirection that you basically check the value of the pointer variable, which will be an address, by the way. Okay, and then you can say, okay, this is the address where the value is stored, and then you go to that address and then you either read or write or whatever you want with that particular value. So the way to declare a pointer variable is like this. You use the asterisk operator. By the way, guys, can you see my mouse pointer? No, right?
No, sir.
No, sir.
No, sir.
That is the problem. That is the problem. I actually did not realize that in the previous lecture. I'm not sure how to do this. Okay.
So you could use the laser pointer.
Yeah, thank you. Okay, so is it the pen thing or whatever it
I
is?
think so.
Laser pointer, got it. Yeah. Now can
Yeah,
you
now
see
it's
this?
visible. Yeah.
Ah,
Yes.
okay, okay. I forgot this to do this in the previous lecture. Anyhow, so so basically this is what happens. So there is an asterisk here, right? This asterisk is essentially, it is saying that this is not a regular variable, this is a pointer variable. Okay, so when I declare something like this, int asterisk p, what it means is p is a pointer variable that points to a variable of type int. So this is important, that pointers too have these types. Okay, what they mean by type is they are actually going to point to a integer variable. So when I say point, it means that they are going to store the address of a variable of type int. So now if I want to store the address of a particular variable in this pointer variable, this is how I do it. I use the ampersand operator. Okay, so I do something like this: int asterisk p, int I. So I is my regular variable whose address I want to store in p. So I do something like this: p equals ampersand I. Okay, so essentially ampersand I represents the address of I, the memory location that stores the value associated with I. Okay, so it is something like this in the memory. at some point, at some place in my memory, the variable I is given space. So this, let us say it is given these. So because I is an integer, on most systems it will be 4 bytes. So basically they have it, it has been given space from 1001 to 1004. Okay, and this is what I looks like. There is a value 5555, and then what this p is actually doing is it is storing 1001. Okay, so this is the difference. P is not storing an actual integer. It is not 1 2 38 minus 2 minus 5. No, that is not what p is storing. P is storing it is storing an address. And what is that address? It is 1001, the starting address of I. Okay, so this is the difference between a regular variable and a pointer variable. A pointer variable also requires space, by the way. Okay, within the memory, it is also going to take up some space. It is going to have, the properties of a variable also apply to a pointer variable, right? So it will be required to be allocated some space in the memory. But what it stores, it actually stores the address of another variable instead of a value. So this is the difference between I and P. So now this asterisk operator can be used to dereference an address. So what does it mean? So it means that if I actually want to go to the location of I, for example, in the previous example, I'll have to use the asterisk operator in front of my pointer. So something like this. If I do printf, the value of I is %d. I can write either I here or asterisk p. So basically, in this context, I read asterisk as value at. Okay, so when I'm reading this code and I'm pronouncing it, I basically say printf, the value of I is %d, comma, value at p. So I'm basically going to read it out as this asterisk as value at. So what it means is p is essentially an address. It is storing an address, and whatever is the value at that particular address, that is what I want to pass to printf. This is the idea. So this particular statement is going to print the current value of I, that is 5555. Now, so basically these ampersand and
No, sir.
asterisk. Yeah, go ahead.
Sir, please repeat
Sir,
this
if
part
we,
again.
There is
sir,
someone
I
some.
have a doubt.
Yeah, go ahead.
Sir, if we not put the asterisk in the printf statement, then it will print the address of I.
Yes, it's just that you'll have to use a different format specifier. %d is for integers. You will have to use %p. Okay, and
Okay,
then
sir.
you can
Okay,
write just p.
okay, sir.
Okay. Yeah. So someone else was saying something at the same time.
Chana got it, sir.
Okay. 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 So then basically this
Sir,
ampersand. Yeah, go ahead.
sir, is it like int I is a variable, p is the address of variable, and
Mhm.
star of p is again like again the variable itself?
Yes, yes, yes. It is again the variable itself. So,
Okay,
so
sir.
what exactly do that is what, right? So a variable is kind of an alias of a particular memory location, right? And asterisk p is doing the same thing. It is going to give you the access to the same memory location. Okay, so then essentially this ampersand and asterisk are kind of complementary to each other. Okay, ampersand applies to any C variable, and what it means is simply return the address. So in this case, I basically read it out as something like this: P equals address of I. So this is value at, and this is address of. Okay, this is the difference between ampersand and asterisk. Okay, so they are kind of complementary to each other. So the only difference here is ampersand applies to all C variables, whereas asterisk applies to only pointer variables, right? Because only pointer variables store addresses. Okay, regular variables store values. So asterisk applies to a pointer variable, and ampersand can be applied to any C variable, including another pointer variable. And to print the addresses using printf, this was the question that someone just asked. Just you'll have to use the %p format specifier. You might get certain warnings on some systems, but on most systems this should work without any error. And this was what I was trying to say, that ampersand can actually be used with any type of variable, including another pointer variable. Okay, so something like this is perfectly valid. I have a pointer p, asterisk p. I have a variable I. I'm doing p equal to and I, and then I'm declaring this int double asterisk q, and then I'm assigning the address of p here. So what this double asterisk is, so basically this what the way to read this is, q is a pointer to integer. This is the idea, right? P is a pointer to integer and q is pointer to integer. So you can have any number of asterisks here. This is the idea. Okay, these are basically different levels of redirection. And if I actually want to go and reach this location, the location where I is being stored, I have to do the same thing, right? I have to put those many number of asterisks, and I will reach this location. So you have to understand this, that here q is storing the address of p. Okay, wherever in the memory p is, q is going to store the address of that, and p instead is going to store the address of I. Okay, the value of p is basically the address of I, and the value of q is address of p. Okay, and the two asterisks. Okay, again this, um, when I'm actually taking live lectures, this is the problem. I just a minute. The webex, webex footer comes in between. So just a minute again. Laser pointer. Okay, so here q is a pointer to an int variable. Okay, so let us just see this example. I have a variable I have a pointer variable p, and I have a pointer to pointer variable q. Okay, and I can actually access I either directly like this or using asterisk p. So this asterisk p is equivalent to I. So if I do plus plus asterisk p, it is basically equivalent as saying plus plus I. And I can also do the same thing using plus plus asterisk q. Okay, so so basically it is levels of redirection. um, they are essentially accessing the same memory location, this as well as this. They are going to change the value stored at the same memory location. It is just that the levels of redirection are different. This is going to be a two level redirection, this is going to be a single level redirection. And if I do something like I equal to 555, a direct direct access to that location. So if I run this code, you will see something like this. The address of I is something like this, and then where the value of p is the same as the address of I. This is the idea. This 3104 and 3104. So the value of p is the address of I, and the value of q actually is this. Actually, I have not printed it. I should have printed that as well. The value of q, if you try to print it, it will be this, the address of p. Okay, and I can actually, and this 5555 is getting incremented every time. Okay, the final value of I is 5557. So this is the basic idea, that if you declare another pointer variable, and so this is storing the starting address of p, and p is storing the starting address of I, right? So p stores 1000 1001, and q stores this 1200 So we can, and I can have another level of redirection. I can declare something like int asterisk r, and then give it equal to ampersand q. So in that case 1201 will be stored in the look in the variable r. So this is the idea. I can actually have
So,
n. Yeah, go ahead.
so if we put only one asterisk before q and say int asterisk q is equal to ampersand p, will it throw an error?
Int yeah, it will throw an error. It will throw an error.
Okay, thank you.
Yeah. Any more queries? Okay, so something like this. So let's now move ahead. And the amount of space that a pointer variable takes, it depends on your platform. Okay, Now, I know some of you have access to that old Turbo C++, right? So if you use that Turbo C++, the size of a pointer will be 4 bytes. Why? Because the size of the pointer is decided by the maximum address that you can store in that value, right? This is the idea. The value that a pointer stores is an address, right? And so the width that I require for a particular pointer variable is dependent on the maximum address that I can actually store in it. Now, on some machines, if the maximum possible address is only up to 4 GB of space, I do not require more than 4 bytes to store it. Okay, and that is why on older systems, on 32-bit systems, pointers used to take 4 bytes of space. But on newer systems, as soon as we actually went into the on the on these 64-bit systems, the pointers these days take 8 bytes of space, because you may need to store an address that is in a that is being addressed in a memory which is in excess of 4 GB of RAM. This is something that I should just tell you that when I started programming, the RAM that I had on my PC was only 128 MB. Okay, so clearly, and the system was a 32-bit system, and when I used to run Turbo C++ on that, it only required 4 bytes of space. But today, almost all the systems, right? They are 64-bit systems, so the pointers there will take 8 bytes, and I guess now it is kind of become a standard that even on 32-bit systems you might actually see, because the compiler by default gives 8 bytes of space. I mean, it might mean that you are wasting 4 bytes, but I think today all the pointers are 8 bytes. So just forget. Actually, I should not have put this in the slide itself. Pointers, for you, you should assume that pointers take 8 bytes of space. But irrespective of how much space they are taking, whether it is 4 or 8 bytes, in all cases, all pointer variables take the exact same amount of space, right? So irrespective of whether they are pointing to an integer, whether they are pointing to a float, whether they are pointing to a double, or whether they are pointing to another pointer variable, okay, the amount of space that they will take is exactly the same. It's not like a pointer to a double will take more space as compared to pointer to an integer or pointer to a character. They are all going to take the same amount of space. Why? Because essentially their content is an address within the memory. So that is going to be exactly of the same size. So here, if I have also put some size of statements. If I print this, in on the console, you will actually see like this. That's the size of I is 4 because it is an integer. It is 4 bytes. The size of P is also 8, and the size of Q is also 8. So even though Q is pointing to a pointer and P is pointing to a integer, any pointer variable, irrespective of the number of redirections, it will always take the same amount of space. Okay, and usually it will be 8 bytes. Now, you can also do some kind of pointer arithmetic. It is probably wrong to call it arithmetic because you cannot multiply or divide pointers. But yes, you can add constants to a pointer. So you can add 1, 2, 3, 4, or subtract 1, 2, 3, 4, something like this. So you can basically add or subtract integer constants from a pointer. So what does it really mean when you are trying to add or subtract from a pointer? It is basically equivalent to saying that now this pointer is supposed to point to the next or previous variables of the same type, of the respective type. So what do I mean by respective type is something like this. For instance, let us say you have a pointer that is pointing to a character variable, a char variable, right? So char data type, it takes 1 byte of space. So if I actually add 1 to a pointer, it will now start pointing to the next byte in the memory, because chars only take 1 byte. But if I add 1 to a pointer of integer type, it will actually jump by 4 addresses. So if it was currently pointing to 1000, if I add 4 to it, it will start point. If I add 1 to it, the value of this pointer will become 1004, right? Because the idea is this arithmetic that we are doing, it is dependent on the type of the pointer. So there are certain things you have to understand. The actual amount of space that a pointer takes, that is independent of its type. But when you actually start adding or subtracting integers from that pointer, the actual effect will be dependent on the type of your pointer. Okay, so something like this. Let us say now, and this is why it is also dangerous actually to 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 use pointers and pointer arithmetic like that. So basically, what I'm doing here is there is a variable dummy, and then there is a pointer asterisk ptr, and I'm just storing the address of dummy in this ptr, and then I'm doing something like this ptr plus plus. Okay, it is similar to how I could have also written ptr equal to ptr plus 1. It is exactly the same. The plus plus operator is doing exactly the same thing here. Now let us see what is happening here. So so in the beginning, the address I had was this. And by the way, when you will print addresses using this %p, the value that will be printed, the address that will be printed, it will be in hexadecimal. Okay. So again, this is something related to number systems. Hexadecimal means base 16, and these things will start with 0x. Okay, 0x here actually mean that this particular value is a hexadecimal value. Okay. Okay, so when I started in the beginning, the location where which I started, the pointer ptr was pointing to this location whose in end digits are something like this 1c 7c. So in hexadecimal, actually c means 12. Okay, so hexadecimal has in it has 16 digits, so 0 to 9, and then you have a b c d e f. So c essentially means 12, and when you add 4 to the 7c, it becomes 16. So it is similar to saying when you add 2 to 8, it becomes 10, right? So the ones digit becomes 0 and the tenth digit becomes incremented by 1. So the same thing is happening here, that when you are adding 4 to this 7c address, it basically it becomes 8 and 0. So this is like hexadecimal arithmetic. I'm not going to go into detail, but essentially what is happening is when I did ptr plus plus, it got incremented by 4 memory locations. Okay, and that is why we are having 80 here and not something like 7d. Now this is where another problem comes in when it comes to pointer arithmetic. You'll have to be extremely careful when you do this kind of pointer arithmetic, when you're trying to add some number to a pointer or subtract some number from a pointer. Why? Because you might actually end up in some kind of illegal memory manipulation. Okay, now what exactly is an illegal memory manipulation? So this program, what exactly is this program trying to do is it is trying to produce a segmentation fault. Okay, so now this is a do while loop. It is, you can see, it is an infinite do while loop, and it is just to show you what will happen if you keep on incrementing that particular pointer, and trying to write something at the next location, and then the next location, and then the next location. What will happen? This is what this particular program is trying to do. So this is what happens when you run this, like after one more iteration of that loop. It says that I'm attempting to write at this particular location, and then this location is an illegal memory location, and you see something known as a segmentation fault. Now some of you might have already seen this term segmentation fault, especially some of you had seen this when you were doing your assignment last week, where you were trying to copy stuff from one array to another array. Some of you actually did see what a segmentation fault is, and I did reply back to you guys on email that there is some kind of corruption in your memory. You are trying to overwrite, you're overwriting a particular memory location in a way that you're not able to understand. So all these things happen because of pointers, because arrays and pointers, they have a very strong relationship. In fact, in the next lecture we are going to talk about that relationship only, that how arrays and pointers are related to each other. They are so related that in the reference book that I have suggested on by Dennis Ritchie. The chapter is basically together pointers and arrays, because they are usually talked about in the same context. But it is probably better to learn about arrays first and then talk about pointers, because that is the easier way to do it. So that is why I discussed arrays first and then I'm coming to pointers. But anyhow, bottom line, so the idea is, if you use pointers, you'll have to be extremely careful about this pointer arithmetic. Okay, you might actually end up at a particular memory location which is not legal for your program to use. And when I say legal, what it means is something like this. um, I'll try my best to create that lecture maybe tomorrow. But there is another digression lecture that was supposed to be a part of this week. In that lecture, I am actually going to talk about how exactly is a program executed. When you execute a program, what really happens? Okay, how exactly memory is allocated, and what really is a code section, where are the variables stored. Um, it is, again, it is not a part of your curriculum, so it will not be there in your exams. But if you find time and if you find this interesting, do go through that digression lecture once I upload it. It will give you a better idea of what it means when I say uh, pointers may lead to illegal memory manipulations, and there's thus the segmentation fault. But the overall idea, in a very brief, if I try to tell you, when your program is executed by the operating system, some amount of memory, some fixed amount of memory within your RAM is allotted to your program to run everything. And if your program tries to access a memory location that is outside this bound, okay, that is when you are going to get a segmentation fault. So this is exactly what this program tries to do. It tries to produce a segmentation fault. Okay, so I think this was the last slide, so I'm not going to discuss the homework. Yeah, go ahead.
So can you please explain that how address shifted to 4 when we once again, sir?
Yeah. So essentially what happens is, here. So when I say, you understand that when I basically added 1 to, let us say, 5555, the next value was 5556. Okay, or similarly, when I subtracted 1 from 5555, it became 5554, right? Because that is how we do addition and subtraction. But now I am saying that we are trying to add or subtract something from addresses. Okay, so what does it really mean when I say this pointer variable points to the address? Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So when I say that a pointer variable is pointing to address 1000, and then I say add 1 to it, what exactly does it mean? Okay. So maybe the simplest way to say is that, okay, now it should point to 1001. um, Similarly, if I say add one more to it, I should point to 1002. That is kind of the intuitive understanding, that basically there is some kind of a pointer, a physical pointer which is going through a scale. Okay, and when I say add 1 to it, it just goes to the next level in the scale. But this is slightly different when it comes to the programming language. So what basically it says is, each pointer has an associated type, right? So for example, it might be pointing to an integer, it might be pointing to a character, it might be pointing to a double. So the language provides you this facility that when you add 1 to a particular pointer, it essentially points to the next integer or next double or next float, whatever is the type of your pointer. When you add a 1 to it, the pointer gets it's shifted by that much amount. So if your pointer was a pointer to integer, by adding 1, it will not go to 1001, it will go to 1004. That is the idea, that you added 4 to it instead of 1. Similarly, if the pointer was a double type and you add 1 to it, it will go to 1008 instead of 1001. So this, we'll understand why it happens like it is like this because it is very helpful when we are going to use these pointers with arrays. In fact, this is the whole point of it, right? But as of now, you have just we'll discuss it in the next lecture. But as of now, just understand that if you do this kind of pointer arithmetic where you add or subtract stuff from a pointer, it is going to only get incremented or decremented in denominations of a certain value. And what is that value? It is the size of the type of the particular uh, it is the size of the type to which this particular pointer variable points to. Does it make sense?
Yes, sir.
Okay, so what I'll do is I'll just probably
सर जब अपन सर प्लस
yeah,
प्लस
go
कर
ahead.
रहे हैं सर किसी पॉइंटर के अंदर, तो सर जो नया एड्रेस आ रहा है तो उस पर जरूरी कोई वैल्यू स्टोर हो, मतलब फिर उसके अंदर क्या है?
सॉरी, आपका आपका वॉइस क्लियर नहीं था मुझे। मैं अब चैट्स भी देख सकता हूँ। हाँ हाँ, बताओ आप।
सर मतलब अपन जब पॉइंटर में सर प्लस प्लस कर रहे हैं तो उसमें नया एड्रेस स्टोर हो रहा है, मतलब जैसे 100 से 1004 आ गया, तो सर
100
अब
से
सर 1004 आ गया, +1 कर
हाँ
दिया अपन ने,
हाँ 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 हाँ,
तो सर अब उस एड्रेस पे सर कोई वैल्यू स्टोर हो, ये कोई कंपलसरी तो नहीं है, मतलब हाँ
बिल्कुल
अपन को।
बिल्कुल सही बात है। और यही मैंने बताया कि हेलो, हाँ, सो मैंने यही
हाँ
बताया कि एक्चुअली यही रीजन है कि पॉइंटर अरिथमेटिक जो है, अगर आप कर रहे हो तो उसके जो रिजल्ट्स आएंगे वो कभी कभी अनएक्सपेक्टेड हो सकते हैं, या फिर आप कोई ऐसी मेमोरी लोकेशन पे जा सकते हो जहां पर, जैसे मैंने कहा कि वो मान लीजिए इंटीजर है ही नहीं, वो कुछ और था, राइट? लेकिन आपने वहां पर राइट कर दिया, तो अब होगा क्या कि आपके प्रोग्राम में कुछ अनएक्सपेक्टेड होने लगेगा। सिमिलरली ये भी हो सकता है कि वो मेमोरी लोकेशन आपके प्रोग्राम को अलॉटेड ही नहीं थी, वो कहीं और की मेमोरी लोकेशन थी, और आपने उस पर राइट करने की कोशिश की, तो आपका प्रोग्राम टर्मिनेट हो जाएगा, सेगमेंटेशन फॉल्ट हो जाएगा। And this is the whole point of pointer arithmetic, that you have to be very careful whenever you are trying to access a particular location. There will no there won't be any compilation error with pointers. Okay, and in fact, one of the earlier ways of creating these so-called viruses, we should not really call them viruses. There used to be something known as TSRs, terminate and stay resident programs, kind of the early uh, ancestors of viruses. They were created using these kind of things, right, with pointers. So if there is a operating system which does not have a proper way of checking these memory accesses, you can do a lot of things with pointers. This was the dangerous thing with pointers. Okay, Nehal has a question. Ash, why are we doing last bit? Let me just open that code. Uh, is this code that you're talking about, Nihal?
Yes, so the second line, so int asterisk ptr is equal to and
Yeah,
sender.
actually, this is like this. I mean, I have actually merged the declaration and the definition part. Ideally, it is like this: int asterisk ptr and ptr equal to ampersand dummy. This is what it is.
Yes, so this merging, then it works like it understands that we are
Yes.
allocating the address.
Yes, that is what. So basically, the asterisk has a kind of so it depends on the context. Okay, in the declaration context, it is read as something else, and then from there onwards, in the expressions, it is treated as something else.
Okay, sir. Thank you, sir.
Yeah. Okay, Sahil had a question. So, int data type variables address. No, you can't. You cannot. That will result in an error. Yes, Naveed. Actually, we will see the real life application once we look at the second part of this lecture. Then we will understand what is the real world use of this pointer arithmetic. But yeah, today I just wanted to show you that there are so many pitfalls, and you should try to avoid those pitfalls. This was the idea. That is why I wrote that segmentation falter. uh, Store randomly, as in, I don't. What store randomly? हेलो।
सर अपन जब भी पॉइंटर में सर मतलब एड्रेस बढ़ा रहे हैं तो सर उसमें अगर मान एम्प्टी है तो उसके अंदर अपन वैल्यू स्टोर भी कर सकते हैं क्या फिर जो वो लोकेशन है यहाँ
एम्प्टी मतलब जो लोकेशन पॉइंटर में स्टोर्ड है, आप ये कह रहे हो?
पर? यस सर।
हाँ, तो वो लोकेशन आप बिल्कुल वैसे ही एक्सेस कर सकते हो जैसे किसी और वेरिएबल को करते। मतलब आप इंट आई लिखो या एस्ट्रिक पी लिखो, एस्ट्रिक पी आई लिखो या एस्ट्रिक पी लिखो, आई इक्वल टू 5 भी वही काम करेगा जो एस्ट्रिक पी इक्वल टू 5 करेगा। मुझे पूरा क्लियर नहीं हुआ कि क्वेश्चन क्या था आपका।
ओके।
So let's hope it's clear.
For the
Yeah.
garbage value also the pointer. Sir,
Sorry.
for the garbage value also the pointer variable points the
Yes, yes.
address.
Yeah. You can access the garbage value through the pointer as well,
Yes, sir.
right? So let us say I just do something like this: int I, and then I do. And then if I try to print asterisk p, it will show a garbage value. This is the idea. The garbage value that is there on the i's location.
Okay.
Is this what was your question?
Yes, sir.
Okay. Yeah. Yeah. So see, for live lectures, I have to keep my lectures to not more than half an hour so that I can at least devote some time to queries. And this is another challenge with live lectures. If I lose my connection in between, uh, it will be a problem. Anyhow, uh, but any more questions? We actually, I learned my lessons from the previous session, so this lecture went much more smoother. With live lectures, this will be a problem. The section whose lecture is before, they will be at a disadvantage because in the second uh, chance, I'll actually not do the same mistakes as I did in the first chance. Anyhow, uh, this is and the data type. So essentially, the Divya sees like this. They are basically integers. Okay. Pointers are integers. Okay. They are just a special type of integer variables where you cannot do multiplication, division, or you cannot add two pointers. Okay. They are integers, but the kind of operations that are allowed on this are different. That is the idea. They are integers only.
You had the 64-bit systems, the address is a mixture of numericals and characters. So that is why I was
They are
asking.
not numericals and characters. They are basically hexadecimal addresses. They are integers only, but represented as hexadecimal numbers. So they are all integers. Don't think they are characters. They are basically integers only. It's just written in hexadecimal. Okay. So binary is 0 1 1 0 kind of thing, right? Decimal is any number represented in 0 to 9. Hexadecimal is any number represented in 0 to f. Okay.
सर तो मतलब
Yeah.
अपन सिर्फ पॉइंटर को इंट में डिक्लेयर कर सकते हैं ऐसे मतलब और किसी तरह से नहीं कर सकते मतलब डेटा टाइप दूसरा?
नहीं, आप डेटा टाइप कोई भी डाल सकते हो उसका। मैं कह रहा हूँ कि जो एक्चुअल वैल्यू होती है एक एक पॉइंटर में स्टोर्ड, वो हमेशा एक इंटीजर ही होती है, क्योंकि एड्रेसेस जो होते हैं वो आपके इंटीजर्स होते हैं। आप फ्लोट एस्ट्रिक पी लिख सकते हो, डबल एस्ट्रिक पी लिख सकते हो। इट्स ऑल लीगल। They will just point to a float type or a double type variable. That's it. Um, any more questions? Okay, looks like this one worked. Yeah, as I said, right? In some ways, the section whose lecture is first, okay, they are disadvantaged in live lecture setting because I learn from the prior experience, and the next lecture becomes better. So like I forgot that they are not able to see my pointer my mouse pointer in the previous lecture, and then I realized that they were, I cannot understand how confused they would have been, because I would have been pointing my mouse pointer at different places, and they would have just not understood anything. But in this lecture, I realized I should use a laser pointer. Uh, anyhow, okay. So, any more questions on this? We will take up the second part of the lecture on Wednesday, and we will have some kind of yes, right, Sahil. And we will have we won't have any lecture tomorrow, by the way. So because it's a holiday, happy sorry, not Independence, Republic Day. Sorry. What we are going to do is we are going to have a form sent over to you by Shreya. Okay, Shreya is from the other batch. She's going to send a form, and we just have to select the mode of teaching from next week onwards. Okay, whether it should be live or it should be that same old thing. Okay, where I record lectures, I send it over to you, and we have discussions. So we have to select a mode of teaching. Next week it will be the old method only. I will record lectures and I will send it to you, and then we'll have discussion. But we have to finalize our mode of teaching within the next weekend, the coming weekend. Okay, so the reason I'm saying this is because you will have two live lectures this week, so then you can compare the pros and cons of live lectures with recorded lectures and discussions. Okay, so then it's up to you. And uh, another issue that we have to decide upon is Microsoft Teams. So if any one of you have more exposure to Microsoft Teams, please drop
We
me
all
an email.
have, sir.
I mean, I actually I tried, right? I mean, I tried creating an account on Microsoft Teams, and there were so many screens. It basically asked me who you are, whether you are a student or a teacher, educator. That was the term. I selected educator, and then some 3-4 screens it asked me. It asked me to give me my email. Um, Avantika, this was. I mean, someone had tried this, I think. And it was working. Someone sent me an email. I will check who it was. So someone has tried recording in in Microsoft Teams with the free account, and it worked. um, Otherwise I would not even considered it as an option, but someone did send me an email that I have tried recording the lecture and it works. So that is the idea. um, yes, I mean, yeah, you can make it for me. Maybe I'll watch that lecture. I don't know how to use Microsoft Teams. um, See, the extension thing I don't want, right? Because extensions are only going to do stuff at my end, right? So basically, whatever I see in a meeting, that will be recorded by the extension. I want it to be stored at the cloud, okay, at the server end, because there all the streams come to the server. So even if my internet connection is poor, um, the lecture recording will still go through. This is the idea, right? If, for example, on some day if my connection goes off, the lecturing the recording won't happen. This is the idea. That is why I don't want to use these extensions for recording. We can only switch to Microsoft Teams if it is possible. Uh, I'm not sure. So that is why, right? I have no real idea about Microsoft Teams. I don't have any friends also who might. Okay, I do have a friend in Microsoft. Maybe I can ask him if if he knows what is it. Uh, and but I'm not sure whether he'll actually be knowing about their pricing and and all those things. I understand. So that is what I don't want it to be saved locally. I want it to be saved in the cloud. This is the idea. Um,
So we could like there's this idea maybe it won't work, but if you open if you create one Google Meet in your browser and one Google Meet in a private window incognito mode, both will work. So we'll have effectively 200 capacity.
Um, See, I can do that, but that will be a problem where I have to share the screen, right? I mean,
So you can
I'm not.
share screen for both of them, right?
Yeah, I'm not sure. I've never tried it, so I don't know whether if the screen can be shared on two different tabs simultaneously or not. I have never tried. Um, I hope it can. Uh, but then again, these uh, these solutions are all, to be honest, they are ugly solutions, and I really don't want to, do all those. Yeah, jugaad is the best word. So I really don't want to. Um, Nihal, yeah. So Nihal, anyhow, we are going to have this. The next week is shepherding week only. So you will have two samples to evaluate. We have already evaluated the shepherding mode. um, I think the first week, right, week 0 was live lectures only, right? Yeah, the week 0 was live lectures only, and this will be another example of live lectures, and then you have all the samples for the recorded lectures. Uh, I see. The reason I am not sure is because even I don't know what is a better option. This option actually requires lesser effort on my side, to be honest. Okay, because recording and uploading, all that, those things, it actually takes up more time on my end. Live lectures is actually much better for me as well, but I actually used the recorded lecture thing because I thought it will be better for the students. Because for example, let us say, even if I upload this lecture on YouTube, there will be so much noise as in, um, uh, let us say you are listening to the lecture again, in between someone asks a question, so I'll have to, stop and answer that person's question, and then come back to the, maybe that question is not of interest to you, when you are revising. So but in these recorded lectures, it's like one coherent lecture, right? I mean, I speak from the beginning and up to the end, with no interruptions. So I actually thought that recorded lectures will be better for students, but then I received a feedback that some of the students are not happy with recorded lectures. They actually want live lectures. So, I knew that your midsems will go up to Friday anyhow, so you will not be able to watch any lectures in the weekend. You would like 2 days off. So I thought, okay, let's have the live lectures this week. So now you can compare. Okay, you can compare live lectures with the other mode of lecturing. I think the issue is with the other mode of lecturing. It maybe it is a bit more work on the student side, because you have to watch the lecture and you have to be prepared to be a shepherd. So maybe some of the students, um, um, yeah, that is the point, Sahil. This was the idea, that it is, not just concentration. You need a very good internet connection as well, and and even if I upload these lectures, it's not like, uploading is an issue. I'll certainly upload these lectures, but you know it's a different kind of thing. If we were sitting in a classroom, then live lectures was the best thing to do. But in this kind of a scenario, it becomes really difficult, because sometimes my internet connection may not be well, and if my internet connection is bad, then everything goes bad, right? I mean, nothing will be recorded also. So it puts more pressure on me as well, that my internet connection should always work. um, in discussions, even if my internet connection goes bad, you can continue your discussions with the shepherds. As long as at least one of the shepherds connection is working, we can continue with the discussion. So this is the pros and cons. I think the reason why some of the students are not happy with the recorded lectures is because it requires more effort on their part. They have to watch the lectures beforehand and be prepared to be a shepherd. In live lectures, you can simply come in and sit, and after the lecture is over, you can go away. You don't really need to do anything, right? So that is why I am more confused. I'm not sure let me tell you, this is much better for me. From my perspective, I anyhow have to sit for 3 plus 3, 6 hours of time during the lectures because I am here, and other than the 6 hours, I also have to prepare the lecture, record it, upload it. So that takes away my time as well. Okay, so from my perspective, live lectures are always better. But I started off with these recorded lectures because I thought it will be better for you guys. So now it's up to you. You have to decide. Okay, if you feel this is a much better way to study, and I want the students who are doing this course for the first time to voice their opinions more. Okay, you have to understand that those who are experienced programmers, for them this class is anyhow a waste, to be honest, right? I mean, I don't teach anything that these guys don't know. Okay, it's mostly, I'm teaching mostly for you guys so that you can somehow get at par with them. It is very difficult to be at par, but I'm trying my best to push you up. Okay, so your opinion has to be, you have to voice your opinions more often, that I want X or I want Y. Okay, for the students who have done programming before, I think either of the models work, they don't care that much. But you have to voice your opinions more. So anyhow, let us think over this, after the Wednesday lecture. Decide among yourself, um, if it is going to be if the difference between the two votes is not too much, right? So if it's like 55-45, then I'll make a call myself. I'll decide what is better. But if an overwhelming majority decides for one mode of teaching only, so let us say if 70% of people say live lectures versus 30% shepherding, or the opposite, okay, we'll just go with that. But if it is a close call, I will make a call myself. So that is why, it is important that you guys discuss among yourself, and take a unanimous decision, because that will be much better. Don't leave it to me. I don't want to take this decision, to be honest. It is better that you guys decide what is better for you. Okay, so again, happy Republic Day. Sorry for the goof up, and let's meet on Wednesday. And yeah, you guys are celebrating it anyway. I'll be happy to join any online celebrations. I would have actually loved to be a part of the institute on that day. Uh, if everyone was there, I would have certainly joined you guys there, uh, in flag hosting and any other cultural events if you guys had organized it. But if you guys are having anything, oh, then please do send me an invite or something like that, right? If any of your clubs are doing anything, I know I'll be very happy uh, to talk to you guys and be a part of celebrations. Okay, thank you. Great. If any of the clubs feel that they would like a faculty member to be there, yeah, please, because clubs are more informal. So I'm not sure whether they'll be happy with faculty members being there. So, um, but decide upon yourself. Okay, if you guys have anything, I'll certainly join. Okay. Otherwise, if we don't meet tomorrow, we'll be meeting on Wednesday. Okay. Thank you guys. And by the way, we'll have the labs from next week. This week there is no lab. Okay. So there are no labs today. Okay, guys. Bye. Enjoy.
Okay, thank you, sir.
Thank you, sir.
Sir.